All right, hi. This is my first stream. I don't really have a specific target audience, I guess. Just thought I would record it. Um, yeah, but maybe it'll get easier and less awkward once I start doing some of the things that I wanted to do today. So, I had a couple project ideas in mind. I am working on at least I'm planning to work on a programming language. I have a lot of project ideas and I want to write them in my own language. It kind of reminds me of themes, color schemes for my editor. I feel like I always change them. And then once I created my own color scheme, which is the one I have, what I'm using right now, I haven't changed it in a long time. Um, Certainly much longer than I've ever kept a color scheme before. So, I mean, that's kind of what I'm thinking with programming language. I know it's obviously a lot more to chew on. I wasn't really satisfied with any of the other options. So I was just thought I should create my own. But there's a lot of steps in there. Um, I think the first thing that I want to do, if I can pull up something, I'm already in the scratch buffer. So my language. And like I said, the main reason I wanted to do that was to use it to write some projects that I wanted to write. And the one project I wanted to write is a proof visualizer, a visualizer for mathematical proofs as kind of a unique take on, I guess, the natural tree hierarchy of a proof. I'm sure we'll eventually get there, and I could go more into that. I actually have a really basic working copy that I had written, was writing in Odin, um, and after a while, I mean, Odin's fine. After a while, though, I just didn't really enjoy writing in it. But okay, so we have my language, and I guess when I say that as a project, I really mean the compiler for my language. And so, in the never-ending scenario where you're writing something and then you need to use a library and you think, I'll go write that myself. So that's where we are at. And, typically in software development, I'd say that that's a bad idea. But if you're enjoying the process, you're doing it for yourself, I don't see why not. And the one library that I did want is a Unicode library. So I'm thinking about writing this compiler in C++. Um, if only, I mean, it's one of my favorite languages, but really I just wanted to be able to use certain libraries, particularly LLVM, with zero hassle above what hassle is inherent to the library itself. And strings in C++ aren't inherently Unicode. They don't inherently have any encoding, so you need a library. I mean, I'd like for my programming language to, as most modern languages do, have a standardized Unicode encoding for what they expect their source files to be and their string literals, etc. So a Unicode library, basically I just want the UTF8 encoding. Okay. So that's what I thought we'd work on, is this Unicode library. Yeah. All right. So I think am I still recording? Just make sure. All right, cool. So, okay. I was working on some stuff, and I don't know if you guys have ever used the default Emacs uh, indentation rules for their C++. I really don't like it. So I spent some time writing this up. I think I'm just going to add this to my init file. Where is my init? Languages, sorry. Yeah. Just throw that in here so that we can get that by default. And close that. Have some changes to pull in probably. Dev Emacs unit.l. It's probably all that I need to worry about. Okay, yeah. That's just what I added. Add git status. This is vim. X C++ indentation style. Add using Emacs key bindings. Add my own C++ style. All right. Save that. Now let's try pulling. Cool. That seemed to have worked. Let's open up Emacs. In the meantime, okay, I don't know why it's taking so long. But, oh, it probably spawned in the background. In the meantime, I wanted to find the reference article that I was using to learn a lot about it. Wasn't this? There's a really great website. Yeah, this one. Oh my god. On my phone, I tried to view this web page and the snowflakes were falling. And my phone probably lost 10% of its battery in 5 minutes. Yeah, just disable that. What's this? What the heck? Okay. So, yeah, this is a really great article. Yeah, maybe I should actually. Maybe I should. 1 second. Yeah, let's look at what's going on here. Jesus. Scrolling out, failed to provide feature. Yeah, I think I fixed this in the other version. I must not have fixed it in this. It's really annoying. Sorry. This is a package that I was writing to. I forgot to provide TM42 scrolling out. I like to prefix all my stuff with TM42s, but in Emacs especially, but general too. Now I'm using VI key bindings. Okay. Save that, close Emacs. Switch to it. Okay, what now? An error occurred. Yeah, I fixed this in the other one as well. Yeah, I should. It's too much work to go push that change. Oh, what was it? I'm just gonna disable it. I don't really want to deal with that right now. I know exactly what section this is in. This is related to that scrolling out stuff. Yeah, let's just disable that. Remove. You guys want to see what I'm doing? Remove the code that uses it. Okay, that should solve it. Cool. And since I actually usually most use Emacs in the terminal, I don't have to set the font in my Emacs config there because it just uses the terminal font. So I always end up using the wrong font here, and I have to change it to what I want, which is Berkeley Mono. Okay, so finally, here, let's just create a, yeah, okay, dev document/scratch.org. Just some Scratch buffer for me to put some information. One thing I wanted to do was add this. All right, this is that Unicode site that I recommend you read. It's very good. Okay, so yeah, we want to parse Unicode. Let me set up the project structure first. So I am trying this thing out where I'm working on this project called Trinkets. And basically what the purpose of this is I write so many utility libraries that I just like them all to be in one place. I don't really want them to all be in their own repositories. Oftentimes they're not big enough at all to even justify that. Oh, 1 second. All right, I'm back. Okay, so what was I talking about? Yeah, this Trinkets library, I found myself just writing the same kind of utility libraries, whether they're per language or cross language. So far, pretty much just been per language. And I thought I'd just collect them all in one place. They're usually not big enough to justify their own repository. So yeah, I think this would be a good place to put the Unicode library. And thinking it's probably going to write it in C++, and possibly, at least for now, we'll target a C++ API. Should be easy enough to make it into a C API, which I could see myself using down the line. Or I'll just re-implement it in whatever language, if it's not C. And I don't want to write FFI bindings. All right, anyways. So yeah, you can see, right now I only have one, oops. Right now I only have one library. It's this tracing library, just facilities for printing to standard out. The include is where we just include the headers for the various libraries, and libs where we include the DUI libs. So as part of the, I guess, the install step, we copy over the header and the compiled dynamic library from these util libraries into these locations, so that if you use multiple Trinkets libraries, you can just use that one, these locations to get everything. All right. Okay. So, what should we call this? Unicode. Yeah. Unicode. Okay. How do we usually do this? Probably might as well just set up the project structure now. Yeah. So we'll have sources. We'll maybe even have build. And we'll start with a CMake lists. So yeah, I'll copy that over from my tracing library. It's just a really simple thing. So what is it? CMake version, project. Probably change that there too. I'll do that later. What is this project? Unicode. And standard 11, fine. CMake C standard required. Add library. Code. I don't think there should be collisions. So I think that name is fine. In terms of namespacing, maybe we can do something. Target include directories. Tracing. What is this? Oh. Yeah. Unicode. Add the source to make source dir. Wait a minute. Do I have in tracing? Yeah, I don't use a source directory. I just put the sources in the file. So I'm just going to delete this. So we'll just have the build. Okay. Executable test basic. We probably don't need tests right now. What is the syntax? That. Okay. Install files. Code. H to the code library. To be honest, I don't really remember exactly what this does, but probably does the right thing. Add custom target. Okay, yeah, this is a test again, so we will just comment that out. Okay, so we said we would start with the Unicode.c and Unicode.h. Just get something simple to make the compiler check fragment once. Yeah, let's just put this all in a namespace. I always forget if the namespace needs to have a semicolon. It doesn't look like it. Sorry, I know this font can be small. Okay, yeah, I don't think so. Okay, let's just not put anything. Honestly. Let's just make a unicode.cpp. Let's include unicode.h. Right. And main. So yeah, got the 4 space indent from my Emacs style that I wrote. Otherwise, I think it's 2 by default. It uses the really weird GNU style. I don't know if you guys have ever seen this. Let me just Emacs source. I just want to show you like kind of what the style looks like. It's pretty crazy. I don't know. Some random file. Yeah, look at this. Okay, that's admittedly not that bad. Yeah, the space after in between the function call and the thing. Yeah, I just didn't like it. I wrote my own. Yeah, okay. Should we do I would just use my tracing library to print out. I don't think I should, because I don't really want to have that as a required dependency. Maybe there's some way to have it as a conditional dependency. But okay. What is the... It's IO stream, right? I forget. Yeah, you know what? I don't really want to do the freaking C++ stuff. Print. I want to use printf. Hello. Okay. I should return a code. Okay. Now let's just compile. I should probably set up compilation to be happening in the right buffer. Unicode build. See. Yep, it's not a C file. Okay. Now that I think about it, my tracing.c is in the cpp trinkets directory. That doesn't sound right. CMake. Cannot determine link language for target Unicode. Probably. I don't know if that's... Okay, yep, that worked. I was just guessing that it uses CXX. Alright, now here, compile with just our make. Look at that. And I assume if we run whatever... Yup, it compiled as a library. Okay, so I guess if we should probably do the freaking test. What did it do? Test slash... So create a tests directory. What did it call it? Just use... Right, call it basic test.cpp. Include Unicode.c. Main. I'm just going to define a dummy function and have the this thing do it. Oh, it's going to make me indent for whenever I'm in a namespace. I don't really want it to do that. Should I just do it now? Yeah, okay, why not? Syntax. There's some Emacs function that says what syntax rule is currently active. I know I was asking chat about this. Yeah. Show syntactic information. Show syntactic information. Okay, diff fun block intro. But the namespace is not a function. Wait. I'm actually in a function, what does it say? Yeah, it says defun block intro. What the hell? Let's just see what they say online, right? Emacs C indent in namespace. Press C++. Okay. Yep, someone is gonna have it here. Okay, I have that A list somewhere here. Yeah, see off its A list. So it looks like we're just adding something here, namespace. Okay. So if I eval that, still has it, but maybe I just need to toggle the mode. Nice. All right. So it's not forcing us to do that weird stuff anymore. So let's just say void foo. And in the CPP file, let's just make this foo. Include it in our namespace. Okay. Now let's go to our test. Okay, so that should do that. We have to target link libraries. Link it to Unicode. Don't need this just yet. This just is like a thing that runs all the targets, like make test. Okay, so we have our basic test. Let's try compiling ds. What's our compilation command? Make. Will it make everything? Okay, it's not basic.c, but it does look like it was making everything. It's basic.cpp, basic test. Yeah, I think it should be called basic. If it's altering the test directory, we don't need it to do that. And this is the best way in Emacs to rename something is indirect, because otherwise, I just haven't had many luck with anything else. Okay, I don't want you to match basic.cpp. Ah, shit. It added the space. How do I get it to reject the suggestion? Look it up. Type out the name. MJ. Add a J. I have to remember that. Meta J. can do anything. Complete Fido exit is the function, so let's just see what it's bound to. Complete Fido exit. Not bound to anything. Is that how you do it? I don't remember. Global set key, KBD. Yeah, just need to quote it. Unless it's bound to something. I think so. Okay. CPP, meta J. Okay, I don't even think it's recognizing this key binding. Does it recognize control meta J? Okay, just make it that. I don't use that command. Can we please rename this file? Cool. Eventually that should probably make it to my config. Okay. Yeah, see, the other nice thing is that it automatically will rename the Emacs buffer. Okay. Compilation. Sure, save that. What do we got here? Void function foo should not return. Unicode. What? Unicode. Okay. Alright. Cool. Got that working, and test basic should, alright, there we go. Okay, we got the basic project set up. Nice. Alright, hi. I'm back for the second day. Last we left off, we just done a basic test. Today, let's actually get started on doing the Unicode. Okay, few things to do beforehand. I moved the init changes that were causing the startup issues over from my other machine, so I should probably pull those down. Okay, let me just commit some of this stuff beforehand that we did. Okay, like the namespace thing. Yeah, and this stuff I fixed in the other chain, so we can not do that. Okay. This I also did in the other thing. And let's pull down those other changes. Git pull. Okay. Hopefully that worked. Yep. Startup, no issue. Okay, we're gonna have to change the font back to Berkeley Mono. And I realized I should probably just increase the font overall instead of having to always zoom in so you guys can see. 18. It's way too small. 36 maybe. Yeah, that's fine. Alright, a little big, but So what are we doing? We were going to start doing Unicode. So I was doing some reading offline, and like I said, we want to be parsing UTF8, and they have this standard that basically explains Unicode and in particular UTF8. So I mean, this library is just for kind of parsing UTF8, and we don't really, at this point, need to like render anything, you know. Um, so I think we should just look at how to parse UTF-8 without having to read the whole manual. Let me zoom this in. Okay, latest version, Unicode 16. So I was looking at this and specification, technical core specification per chapter web pages. Yeah, this is what we want. And I heard it was chapter 3.9. Yep. 3.9.3 UTF8. It's actually a pretty short section, so I mean it's from here and scrolling down, 2 tables, done. That's it. That's this section. And they pretty much tell us how to parse it. The first thing, so I guess I should say a little bit about what we want to parse first. Unicode for developers. I wrote this somewhere, but yep, this site. Turn off these snowflakes. Please do not. Okay. And he has this really nice diagram here. Yep. Okay. So there's at least 2 major concepts in Unicode, my reading of it. There's the code points and the graphemes. The grapheme is what we would think of as a single character. The code point is a kind of like the atom of Unicode, I guess. It can correspond directly to a grapheme, as in like the simple ASCII case, or like we see here with the E with the accent, it can, 2 of them can combine to make a single grapheme. Each code point is in UTF-8, a code point is anywhere from 1 to 4 bytes. So the way I'm thinking about this is, first we want to parse code points. And basically what that would mean is get something, yeah, just parse code points, basically be able to iterate over code points. So that means you have a stream of bytes and you parse something, the algorithm will know whether you're parsing 1 byte, 4 bytes, return that information, return the code point. The second step will be to parse graphemes. So a sequence of code points can constitute a grapheme. It isn't as simple as the code point. There's actually, as far as I can tell, based on my reading of some of that material, no range of code points. You can't say like, oh, a grapheme is anywhere from X to Y code points. It could be any number, and I guess the algorithm is more involved and it's called text segmentation. Okay. But for now, I think if we can parse code points, that would be great. At least that's the start, right? We'd need that anyways to do 2. So, yeah. Let's open up the project. Trinkets, where are we? C++, Unicode. All right, here we go. We look at the specification. A code point is 1 to 4 bytes, and you can actually tell by looking at the first bits of each byte. So we can see here that if we're looking at a 1 byte code point, it will start, the first bit will be a 0. And if we have a 2 byte, the first bit will start with the 1, 1, 0, second byte will start with the 1, 0. So these continuations, if you see, even that's the case for the 3 and 4 bits ones. I guess these are, I've seen them called continuation code points, but they will start with 1, 0. The first one will start with either 0, 1, 1, 0, 1, 1, 1, 0, or 1, 1, 1, 1, 0. So just by looking at the first byte, we can tell how many bytes the whole code point is. Then there's this table, which tells us whether the byte we're looking at is well formed. So if something went wrong, that it means it didn't match like this pattern, and then we should error correct in the sense that we should go until we're at another valid starting point for a Unicode code point, which is one of these. I'm not too sure on the API for that sort of thing just yet. I have a pretty good idea, but first I guess we should start with this. So that's enough talking. Let's start doing this. So I thought we would just put all the code point stuff in a file called codepoints.cpp. So I'm thinking, so like you see here, we created this unicode.h. I'm thinking we just have a single header. Maybe we should have a UTF8 header. Right now we are only planning to support UTF8, but I guess if in the future we support UTF16, we can think about whether we want that to be in a separate header or the same header. But for now we have unicode.h. And so we'll define even the functions here. We'll declare them in that header. If you didn't know, there's no like rule that you need to have the header be the same name, I guess, as the implementation file. The header could be called anything, or could the implementation file. All right, so yeah. I guess the first thing is to determine how many bytes are in a code point. How should we do that? So static int code point size. Next, code point size. This will take, let's say, a sequence of bytes, and will return an integer, which will be the number of bytes of the code point starting at, well, wherever the pointer is starting at. So how should we do this? We just need to look, I guess we just need to look at the first one, right? So it should actually just take a single byte and just return first. So the parameter should be first byte of code point. And let's just call this code point size. Mm-hmm. Is there a specific UA type? I would much rather use that. Hmm. Okay, so it looks like if we just include, this is the implementation file. I'm fine including some of C++ specific stuff. Do I want this to be? Okay. I mean, I don't know if I want this to be a public function or not. We can decide that later, though. Let's just... I mean, this is really annoying. I just wish it would be called U8. Actually, you know what? I'm going to ask ChatGPT how can I define a def in C++ called U8 that is portable. It can leverage portable. Okay, I'll just do this later. Okay. First byte of code point. So we just need to look at the first byte and look at the first bit of that byte. Does this actually say, like, what is the first byte of a, what is the first bit of a byte? Is it the least significant or the most significant? This stuff always confuses me. Okay, does it have endianness? Okay, machine architectures differ in ordering. Okay, when a process interprets a byte sequence which it purports, it shall interpret that byte sequence according to its byte order and specifications for the use of the byte order mark established by the standard. Machine architectures differ in ordering in terms of whether the most significant byte or least significant byte comes first. Okay, that's endianness, yeah. For example, when using UTF-16 LE. So does it just match the endianness of the whatever system you're on? I mean, that's confusing though, right? Like, this is UTF-16. Oh, I'm stupid. Endianness talks about the ordering of the bytes, not the bits. So is the first bit the most significant or the least significant? Most significant or least significant? Table 3.6 specifies the bit distribution for the UTF-8 encoding form, showing the ranges of Unicode scalar values corresponding to 1, 2, 3, and 4 byte sequences. Yes. What does this mean? Does is the most significant bit written first? I think so. Okay, in the early days of computing, it was common to number the most significant digit bit 0 because mainframes dealt in floating point values, and having it this way round meant that the units would be at the top in the highest bit. Okay. If we were using decimal digits, this game, for integers, it makes more sense to number the least significant digit bit 0. I would ask ChatGPT, but I don't want it to be wrong. Am I barking up the wrong tree? Specifies the bit distribution for the UTF-8 encoding form. The UTF-8 code point sequence is represented. Okay, I'm just gonna ask chat. In Unicode, we can UTF8, we can tell something by the first bits of the first byte, the byte we are currently looking at. Does this mean the most significant bit or the least? That chat says most significant bit. Where is this referenced in the Unicode standard? I mean, it sounds like it's just saying that, okay, this is how a human would write the byte. A human writes it most significant bit first, i.e. most significant bit most on the left. And therefore, this is the most significant bit. All right, so how should we do this? Well, we need to, I'm just wondering, okay, so obviously we could first look at the most significant bit. If it's 0, then do this. If it's 1, then look at the next significant bit. Seems inefficient. It seems like there's got to be a way to do that. I mean, we can't just grab the first 5. So to detect if, let's say we grab the first 5 bits, most significant bits. If we were to it's really a matter of where the first 0 is, right? Yeah, if the first 0 is the most significant bit, then it's a 1 byte sequence. If the first 0 is the third most significant bit, it's a 2 byte sequence, 4, 3, 5, 4. So I guess we seek until gosh, I'm just trying to think like how could we easily express this in in using bitwise operations? You know, instead of having to rely so much on conditionals, if there's like just some clean bitwise operations that can keep that to a minimum. Mm. All right, let's just think about this out loud. So it's either 0 or 110, or 1110, or 11110. So obviously we could look at the most significant byte. What else could we do? We could and until no. XOR until true takes up to 4 times, right? That's basically the same thing. So, yeah, if you don't know what I mean like first, so what does this look like? First byte of code. It's like, this basically just means like, and with, I don't know, like whatever thing you're interested in. 1, 2, 3. Like you and with that. And then you and with this. And you keep going until that gets you the first thing. And then you need to check if it's 0, 1. I think this is a little bit better. You XOR with this same thing. Right. And so like here, if it's 0, and you were to XOR these two numbers together, wait, I'm confusing myself. What does it mean to XOR a byte? Yeah, it just does bitwise. And then you need to look at the first one. All right, let's just do the most straightforward thing. So we want to check, okay, so we want to check the first time it's 0, right? First byte of code point and whatever that number is. Mm. 2, 4, 6, 8, 10, 12. Am I stupid? All right. 0. 2, 4, 8, 16, 32, 64. God damn, I'm so dumb. 64. 6 zeros in front. Yeah. If that, return 1. Wait, if that is, its first bit is 0, then return 1. If you really want to be looking for when the first. Okay, so now you know first bit is 1. No, so we don't really want to AND with 64 because then all these are 0. We want to AND with 1 shifted 6, right? I write 1 shifted 6. No, 1 shifted 7 minus 1. 1 shifted 7 minus 1. Just jump it to Python to verify this. I don't know, how does fucking Python do Python? Looks like you can do b.format. Okay, 1, 2, 3, 4, 5, 6, 7. 7 ones. That's what we want. If that is. So you AND with that. No, I'm a complete idiot, bro. Okay, you want to AND. God. You want to AND with the 1. Yeah, I wrote the right thing. God. I'm gonna do that. If that is 0, return 1. Now you know the first bit is 0. Okay, now you look at the second bit. If that is 0, that's an error. That should not happen. Error. Okay, second bit is 1. Now, wait, don't be stupid. Okay. Let's just copy. Let's just copy this. What are you talking about? Okay. Now you look at the third bit. If it's 0, then you know 2. It's a 2-byte sequence. No, the third bit is guaranteed if you're there. Now just look at the fourth bit. If it's 0, you have a 3-byte sequence. And if it's that next one, okay, 4. Probably return like -1 or something. Probably will want an enum somewhere. Should I ask chat? Chat will probably say that I'm doing this in the worst possible way possible. Let's just ask chat. I mean, maybe there's like, I'm just being a complete idiot, and there's a very simple way to do this. So let's just ask chat. Is this a good way to determine how many bytes are in a UTF? Yeah, I'm being an idiot. I made these off by 1. I mean, I guess you could hard code in the hex. I have such bad intuition about those numbers, so I'm just going to stick. Why is it not? Wait, okay, equals 0. Okay, wait, what is it doing? ASCII 1 byte. If bit 7 is that, that's 8 times 16. Yeah, that's 64. Bits. Okay, if that's equal to 0. So we agree. Me and chat agree on this base case. Okay, if the top 3 bits match this, so they're, yeah, so they're, by checking the whole sequence, you can avoid the, can avoid having to explicitly check like this. Alright, I mean, alright. If first byte of code point Yep, so this is 64. I really hate that, bro. I mean, who knows what that is? I'd much rather, I mean, the compiler's going to optimize it anyways, right? If the first byte of the code point, and so now this was 1 x x x. Now we want 110 x x x x x, right? So what is that? What is 111000? That is quite simply I'm gonna really depend on the compiler to do this, but it will be readable. So it's 1 in the most significant bit, or with 1 in the second most significant bit, or with, wait, 1 in the third, yeah. If that equals, you want it to equal 110, right? So that's 1 shifted in the most significant bit. Or with 1 in the second most significant bit. Yes, look at that beauty. Look, tell me if you would. Tell me you wouldn't want to read that instead of this slop that's ChatGPT spit out. Tell me you don't think this is better. Alright, let's just indent this a little bit better, huh? I'm thinking, can we just name it creatively? Why are there no binary literals, man? Oh. If we commit to C++17, we can get binary literals. It's worth it. That's the sort of ground-breaking decision that will make me want to switch, huh? Can we use underscores? C++ binary integer literals. Let's chat. Can you use binary literals C++ with some sort of separator to make it more readable? Okay, single quote. I think that's probably what that CPP reference was trying to tell us. Optional single quotes, yeah. Why read the documentation when you can ask chat? Okay. Now that is actually better than chats, in my opinion. I don't know about the previous one. Oh god. It messed up my Emacs. Or maybe it's this that's missing it. Yeah, okay. Phew. It did not mess up my Emacs. Okay, 0b. Okay, that is equal to 0b 110 0 0 0 0 0 and return 2, please. Let's change this as well. 0b 1 0 0 0 0 0 0. That is equal to 0. Okay. Return 3, return 4. So the first 4. 1 1 1 0. Yeah, same number of ones as the code points, leading ones as the code point, except for in the 1 byte code point case. Here we look at the first 5 and we want 4 leading ones. And if it's anything else, okay, I guess, you know, even this was not very robust, right? Because that's only detecting one kind of error. If it's anything else, you need to return an error to do error. Makes sense? Cool. Oh, all right. That took way too long for that. What's next? I'm going to let's just forget about how long that took. That's a little bit embarrassing. Maybe we should have a function that says, is this a continuation byte, right? Do we need to? So we know that each continuation byte is in a certain range. That's what table 3.7 is saying. So the second byte for a 2-byte code point is in the range hex 80 to hex BF, which is, okay, hex 80 is 64. So yeah, 1 in the 7th bit. So yeah, starts with 0, 1. And then it's BF. Hmm. Which is 15. So the B is 12, 8, 1. God damn, dude. I do not mess with freaking X. I was pretty off. Huh? Man. So when they say 80 to BF, that means 128 to 191. And we're talking inclusive. But so 0xbf does start with, so a 2-byte sequence, the continuation byte needs to start with the 10. BF does start with the 10. Oh yeah, they both start with the 10. I'm stupid. Okay. Yeah, so what I was saying is that you can just check that it's a valid value for that byte, right? And if it is a valid value, it certainly is a continuation byte. I'm just saying, like, maybe we don't really need a function that computes the continuation byte. But honestly, from this already, like, if we're deferring the actual rendering to like raylib, then we parse the first byte, UTF8, um, I just think maybe this is enough. Maybe it's enough to just look at the first byte, see how many bytes the code point is, just return those bytes. Don't even validate it. If you want a function that checks it is if you want a function that returns an actual grapheme, then you would need to validate it. So, I mean, what does it hurt to validate it, right? Does not hurt. Static. All it is valid code point byte. And it takes two parameters. The first is, we don't need this const. Okay, the first is an int that says num bytes in code point. And then we want to know num byte. Is it the first byte, the second byte, the third byte, or the fourth byte? Right, I mean, probably should assert that num bytes in code. So what we get, num byte is less than or equal to bytes in code point, and this is not an index, so we just want to make sure it's greater than 0 and less than that. And I mean, at that point, why not just also assert that num bytes in code point is greater than 0. Let's make it a uint. That type. I'm too lazy to make this. Just assert that it's greater than 0 and less than or equal to 4. Okay. Is valid code point byte. I guess realistically, you would be doing this in line. I don't really want the conditionals. Oh boy, this is a mess. Okay. What we should do is think about what the final API is going to be, right? So what we're going to do is static uint32t. We'll call it eat code point. And what it takes in is, let's just make this an int, right? Takes in takes in the input UTF8 input codepoint out. So this function returns the number of bytes in the code point, sets code point out to the red code point if successful. Okay. So call this function, right? If switch on code point size of the first byte in the sequence So maybe it should just return 0. This makes more sense. Like, if you're using the return value to know how many... Okay. A0 is success code, right? So let's not do that. So if it returns -1, return it. That is... means you did something. If it is 1... This probably don't even need to do that, right? Just do it as a default. Okay, case 1. That's pretty simple. You just set star code point out equals star UTF8 input. And then return what? So let's just factor this out into a variable. So we can just return the size at the end. Case 2. You see a single line case statement in C that it looks weird because you probably are, unless it's just, yeah, you're probably not doing something right. Probably forgot to put a break in. Let's just write the skeleton, right? Case 3. And actually there is some validation here, right? We need to validate if it's valid. Right. I guess there are some cases where you don't need to validate it. For example, if you are just checking that the code point grapheme, let's just say we're talking about like ASCII characters, you just want to check if the thing you're looking at is this letter. You don't really care if it's a valid code point or not. You just care if it's equal exactly to this value. Though at that point, you probably wouldn't even be using the library, right? To parse, you just directly look at the first byte. So if you're using the library, presumably you do care about validation. You know, now that I'm thinking about it, it makes me think like, if my compiler, remember I'm doing this whole thing because I want my compiler to use UTF8, but if my compiler is, yeah, dude, if my compiler is just going to be checking certain inputs, then it doesn't care, right? If, um, no, like, okay, if the compiler wants to check if you're looking at, if the user has provided a valid identifier and you're like Rust where your Unicode could be in the identifier, I think, then you probably would need to know more than the very basics, right? Unless you say you can only have ASCII characters in the identifier. Yeah. So maybe we don't need this and this was all a waste of time. Um, it's kind of where I'm leaning now, but you know what? Like, it's a good learning experience, right? I'll just go through with just go through with that. Say we down the line we need to write something similar for the standard library. We'll have written it once. So there you go. Okay. So so okay, well the point of that was if you're looking at it then you probably want to do validation too. Okay. And what I was saying is yeah, just as a default return. Again, to do enum. So you want to include the logic there. So static bool valid UTF8 1 byte code point. valid UTF code point 1 byte first byte. So this is a function to check if, so we're looking at a 1 byte code point, looking at the first byte of a 1 byte code point, and we're checking if it's valid. So int8t byte. Bro, do we even need that to be a function? We literally have the freaking thing there, right? If so if it's in that range, right? If it's greater than or equal to that hex and less than or equal to 0x7f, then more like if that is all not true, then you early return the error. Let's just define this freaking enum invalid code point start. So, okay, if the code point size fails, we return invalid start. Invalid. I mean, maybe we should just have invalid code. Set an error string. Do you guys know this pattern? When there is like you have char you just have like an error message that is a fixed size buffer and you use it to fill. In the error message, you signal an error to the user gets more information about the error by reading that string, calling a function that returns the string stored there. How do I define a fixed size char array for storing strings? Yeah, I was just wondering like where the thing goes. So it looks like it's here. So how many chars should it be? I don't know. 256. Right? I'm realizing that I'm writing this so far probably could be fine just being written in C. I mean, for now we'll have. But I feel like we should probably. Okay, let's just have a invalid code point one for now. Right. So we require for this to be the case. If it isn't, return an invalid code point. If otherwise, I mean, so if it is, just set it to that. Yeah. Okay. Case 2, pretty similar probably. So the first byte needs to be like in this range. UTF8 input 0 less than or equal to that. Then that's not true, returning. So yeah, we might as well set message here. First byte of byte not in range. I guess you would say out of range. Not out of valid range. Okay, I'm thinking we need. Just make it like 1024. That's probably enough. First byte of 1 byte code point out of valid range. Okay, what am I doing? Treating this as a function. Set it like that. Okay, yeah, we should probably make this static and then just define a function to get that. Yeah, I mean this probably should be in like some shared header. So we should probably put this in unicode.h. Can worry about that later. Yeah. Error message. First byte of 1 byte code point out of valid range. So here, first byte of 2 byte code point out of valid range. Okay, we also need to check the second byte, right? So if it's greater than make that error message better, byte 2 of 2 byte code point out of valid range. All right. Hello, welcome back to day 3. I haven't touched this in between the last time we were working on it. But I've been thinking about it, and I realized I'm a complete idiot for the way I was doing things. It's kind of embarrassing. But I think by the end of the last video, we sort of figured it out. So where were we? We were in the middle of determining this function, eat code point. So what did we have? So we carried out the second case, second byte being between 80 and BF. So that should do it for the second byte. Right. So now we need to do the third byte. Oh, so this is interesting. The third byte, the ranges are dependent on the ranges preceding it. Like the second byte's range depends on what the first byte was. Oh, I guess we didn't do this. So this is a 2-byte sequence. So we want code point out. Well, first we want it to be 0 in case there's anything there already. Then we want code point out. Well, actually we don't need to, right? We just make it UTF8 input 0 ORed shifted no, that's the first byte. First byte should be the least significant. First bit is the most significant, first byte is the least significant. And the reason I'm thinking that is because it should be compatible with ASCII. So if you have like 128, it's just a 1 byte sequence. You want all 4 bytes, the entire int, equal 128. So it would be in the least significant of the 4, the least significant of the entire 4 byte integer. So I think we do something like this, right? So then we shift this over 8. Yeah, I think that makes sense. Okay. So, all right, now we're on case 3, which there is actually a lot of cases. So if the first byte is E0, we need to do something. If UTF8 input 0 equals 0xe0, right? Then you want to check, then it must be the case that the second byte is between A0 and BF. A0 and BF. That isn't the case, you have an invalid codepoint. So now you know it is the case, so the third byte must be between 80 and BF. And so we do a similar thing. So if that isn't the case, you have another invalid code point. Otherwise, you successfully found a 3-byte code point, and we just set it UTF8 input 0, ORed with UTF8 input 1, shifted 8, ORed with UTF8 input 2, shifted 16. Let me just fix the indentation a bit. All right. Just figuring out what's the most aesthetic. All right, that's fine. Did I shift 8 or 7? Am I off by 1? 1 shifted 7. 1 shifted 1 will result in 2 bits. if you were to shift it, so if you were to shift it over 8, it would be in the 9th bit. Yes, I think that's what you want. So that's the case if the first byte is E0. Could also be the case that the first byte is between E1 and EC. So it's greater than or equal to E1 and less than or equal to EC, right? E1, EC. So if that's the case, what can we say about, so then we expect the second byte to be between 80 and BF. So if that is not the case, right, that's an invalid code point. So, and if it is the case, then we expect the third byte to also be between 80 and BF. I'll honestly do the same thing, but instead, oh. Alright, so if you're here, you're fine. Actually, we can just put this somewhere at the end, perhaps, because it's the same logic. So what I'm thinking is just break. But not yet, not yet. Something like that. So this should probably be else if, right? Okay. So now if the third byte is ED, then the second byte should be between 80 and 9F. Between 80 and 9F, and if that is not the case, it's invalid. Then the last one should be between 80 and BF, which is what we're doing here. Right. The fourth case, if the first byte is between EE and EF. EE to EF. EE. EF. Then the second byte and third byte have to be between 80 and BF. So same as here. So, I mean, you could probably combine those two cases. Whatever. And if you're not any of those cases, that's bad. Is that even possible? Yeah. I don't know. We'll just put a case in. So now onto the 4-byte code points. Ooh, it's turning into a monster function, huh? So we did case 1, case 2, and one case 3, right? So if the first byte is F0, then the second byte between 90 and BF, so if it's not between 90 and BF, it's invalid. The third byte is not between 80 and BF, it's invalid. And if the fourth byte is not between 80 and BF, it's also invalid. Otherwise, it's valid. And we'll do the actual setting of the code point at the end, like we did in the previous case. Wait, this should be case 4. Okay. Just copy all of this, maybe. So if the first, I do an else if the first byte is, where are we? F1 to F3. So greater than or equal to F1 and UTF8 input is less than or equal to F3. Then the second byte should be between, and all three remaining bytes should be between 80 and BF. Man, I should really probably be collapsing these into a single one, right? So if it isn't the case that the first byte is in that range, and the second byte and the third byte, or the second byte, third byte, and fourth byte, then it's invalid. And do something similar here. Much cleaner. Alright, the last case is if the first byte is F4. The first byte should be between 80 and BF. Wait, 80 and 8F. I mean, the second byte should be between 80 and 8F. The remaining third and fourth byte should be between 80 and BF. Nice. And if you're not one of these, you're invalid. Right? So then we just set codepoint accordingly. Okay. Something like this. I mean, I guess the one thing is that we're no longer giving a super detailed error message, but honestly, that's okay. So what can we say? Honestly, I'm just going to remove the error messages for now. And we can do more of this. So case 2, there was only one case, right? Yeah. Just combine these so it looks a little nicer. Last case. And even these could be combined, right? So Do it for the 4-byte one as well. All right, that should be good. Yep. All right, let me just go turn off my washer. Okay. So, let's actually think about the API we want. So if we go to unicode.h, what I'm thinking is we, because we're leaving the door open for if we want to potentially do something with different encodings, so I'm just going to put it in also a UTF8. So, let's put in a UTF8 namespace. And then I'm thinking like across each of them, we have the same sort of function, which is int eat code point. That's what I called it. Oops. Yeah. We'll call it eat code point. And we'll just make it we'll take whatever arguments was taking. Consume a UTF8. I guess we're not eating it. We're really reading it. Read code point. Read the UTF8 code point. Starting at the input. If successful, the value of the code point will be stored in code point out. And the number of bytes in the code point will be returned. Number of bytes the code point occupied in the input will be returned. We should probably say this function validates that the code point is well formed. If not successful, return this returns invalid. What was it? Invalid code point. And let's move this here. Oops. Oh. Then for the sake of safety, we should say this function may read up to 4 bytes from the start of the just because so it's up to the caller to ensure you have at least that much space in the string. I guess, I mean, you don't have to, but just so the caller knows, we're not going to just potentially keep reading and reading. Though, like, if it was an end of file, like, you could just end on a 1 byte code point, and that's fine. But yeah. It'd be nice if there was some way to just give, like somehow assert in the signature that you're not going to read past that, but this is fine, because I'm the only user, I think. Anyways, so that's not what we named the function. So okay, that should handle the UTF8. Do we want to just try building it, maybe? Do I have the compilation out? Don't think so. So let's go to shell build. I think we have the same files, right? CMake. Okay. Compile, make. Okay. Can do that. No member named foo. Write the test function. For now, let's just ignore it. Okay, built. So let's just say input okay, let's just try parsing something. Int codepoint TM42 UTF8 as input, let's just give it foo. So we'll tell it to read the code point there. We'll give it code point size right. And then we can just assert that size equals 1 and point equals should equal half. Oh, what was it? Assert header. This is just assert.h. Yeah, okay. Undefined symbol TM42 UTF8 read code point. TM42 UTF8. So I mean it found it because it didn't compile time. So that means our definition. Oh, I don't think I added this to the CMake. So it was called codepoints.cpp. Yeah. I have to go back to you shall regenerate the make file, remake it, holy crap. Okay. I have to change the standard too. Let's just make it 17. I think we needed at least 14. So remake the CMake. Okay, so it worked. A lot of warnings. Result of comparison with constant. With expression of type const char. Oh. Um. Wait, so a char is 1 byte, right? 1 byte is 2 hexes, 2 hexadecimals. How many hexadecimals does it take to represent a C char? Yeah, it takes 2 hex digits. So what is it going on about? Result of compare. I'll just ask it to explain this shit. Can you explain this warning, please? Oh, char is signed by default. Right. Unsigned char. So let's say const auto bytes. Can I convert a const char to something unsigned, like your suggestions, easily without changing my API, which takes a const char? Okay, so it wants me to use reinterpret cast, but I always forget what the hell the difference is between static cast versus reinterpret cast. Static cast, provided that you know the thing pointed to is really an int, is designed to reverse any implicit conversion. With that assumption, nothing is being reinterpreted. Reinterpret cast, if you've omitted details that mean you might actually be reading memory using a type other than the type was written with. And be aware that your code will have limited portability. By the way, there are not many reinterpret cast if you've omitted details. Current. I feel like that guy was close to explaining it. Static cast is the first cast you should attempt to use. Reinterpret cast is the most dangerous. It turns one type directly into another, such as casting the value from one pointer to another. Largely, the only guarantee you get is that normally if you cast the result back to the original type, you'll get the same value. C style cast and functional style casts. Man, what the hell? Static cast. So let me just try static cast first. And replace UTF8 input, except for the first two. Okay. What happens now? Okay, I won't allow it. We'll allow reinterpret cast. Okay. So can we just do this? So it didn't exit non-zero. What if I just change something? Have to recompile. Yep, failed. F, and if the size changes too, it should probably fail. Yep. Okay. I mean, I don't even know if this is like buggy, and this is obviously not totally the right code, but I think for now it's probably enough. So this is what we did. We just have a basic function that just reads a code point. And yeah, we can, so what was the point of this all again? We wanted to I'm thinking like maybe we don't even really need to do this right now, because honestly, I mean, I know I just did like literally the most basic thing, but that was kind of annoying and not. Um, it's interesting, but maybe something revisit. Remember, the whole point was for this was to be able to start working on the parser for the compiler. And I just wanted the source code to be UTF8 encoded by default, right? That was the reason. And there's no really like way, I guess, to UTF-8 encoding isn't built into the C++ standard as far as I know. So, but I mean, if you look at languages like Rust, the reason why this is important is in Rust you can have Unicode identifiers, right? So if you look at like how they define identifiers, it's like XID start defined in the Unicode standard, and then an XID continue. So I mean, as an example, let's do Unicode identifier. This one like show like how this could look. Yeah, so like see this guy, he is using some non-ASCII symbols in his code, obviously. So you can do that in Rust. And if you do that, then you need to, at least in your compiler itself, you need to be able to parse. You definitely need to be able to parse Unicode, probably like down to the grapheme level. Because like, you know, these variables, like omega I, cosine theta I, if you want to like, I don't know exactly how it's implemented, but maybe you maintain a map of local variables, look it up by name or something. You want to be able to look it up by name. So you want to be able to like store, understand what the variable name is. In our case though, I say let's just start with assume identifiers, all built-ins are basically ASCII, right? So I guess then we didn't even really need to do this, but I think it's still useful to have done it, at least to have the, you know, the parsing API and everything will look how it will once we finally eventually do go to support Unicode identifiers and stuff. That stuff will be in place. And so the nice thing about this is that you can still have Unicode string literals, right? So you could have like Unicode string literals in your code in the language that we're compiling, which by the way is going to be called mil for my Lisp. So you can still have Unicode string literals in mil source code. Why is that? Because we're just going to, when we're parsing, we're just going to see, oh, there's a quotation mark or something, indicates the start of a string literal. Then we're just going to keep reading until we hit the end delimiter, the end double quote. We're not actually going to care about what the contents of that string are, at least like down to the grapheme level, right? We could just essentially treat it as a binary blob. So if we're just going to look for the start and end delimiters, they're both ASCII. We don't have to understand anything more than ASCII to still support Unicode string literals. Yeah, I mean, it's probably pretty limited what you could do with that with Unicode string literals in mil at that stage. But from the compiler perspective, you're not making any decisions that you're not writing the code in such a way that you're relying on ASCII encoding, right? And hopefully, I would like to eventually support Unicode, have a Unicode standard library, Unicode identifiers, even though I personally probably wouldn't really use them. That will be a seamless transition, hopefully, from the compiler perspective. So all of that to say, I think right now this API is pretty good. Just very simple, basically just a skeleton, basically just useful for ASCII input anyways. But it will give us a good start on the compiler. So what am I thinking about next time? So yeah, the next time, so there's a couple things we can do. The first thing, obviously, is to write a parser. I've written a lot of parsers. I just wrote a basic list parser in Rust the other day, in fact, because I'm nothing if not a language hopper. Rewriting this in C++, rewriting C++ in Rust, and then rewriting Rust in C++ again. Yep, that's me. So we could do the parser. I think that should be, it's definitely work, but in my opinion, it's very straightforward. I think the one thing that I don't have a ton of experience before is providing like good source code information during this phase. Source code information. I usually rely on, in the past I've relied on some really nice Rust libraries to handle that for me. In particular, this Miet. So I started out in my compiler journey working on helping this guy out with his compiler, and when I saw the diagnostics, I was absolutely blown away because they were so beautiful. And at the time, I mean, I didn't know that it was a library, but regardless if it's a library or not, these are absolutely beautiful error messages. So Miet provides, I mean, it's not too complicated to provide a type to store source code information. It's the strength of this library to provide the diagnostics, to print the diagnostics. From even without the fanciness, there's still something to be said about being able to retrieve the source code, know which chunk of the source code to print, stuff like that. So I don't want to depend on a library for that. I'm not even using Rust. Probably something similar for C++, but I think we could do something pretty basic and get functionality-wise like most of the way there. So that's one thing we can do. The other thing, like I said, the end goal is sort of this proof visualizer. And part of sort of the backbone of that is this thing that I've been working on called, in the very early stages, so I can't even say like really I've been working on it. It's a theorem database. It's just a name. I mean, because I realized it might also be useful to store definitions and such, but theorem DB, and that's just a SQLite database that stores basically your proof trees, treating each like step as a node, not therefore, each node is an entry in the database, stuff like that. And so the whole reason I did that was because I wanted to be able to write proofs and talk about proofs in like a visually appealing way. Not just visually appealing, but like also aesthetically appealing, easier to understand even for me. So I started with the proof visualizer idea to do that. So I'm like, oh, I want to talk about this theorem. I was doing I just picked a simple theorem, right? Monotone class theorem, and I wanted to talk about it. I'm like, oh, it'd be really nice if I can make a video on it. And for that, I was like, oh, make a proof visualizer. That'd be great. So that's already one level of indirection. And then I was like, you know what? I started on that, and I was like, you know what? I don't like this language. I just want to write it in my own language. And then that's how it came up, like, I want to write a compiler for the language because I want to write my actual project in my own language. That's a lot of levels of indirection. And the reason I'm saying in this is because actually instead of just waiting until we do all that work to write a whole language before we make a video on the monotone class theorem, we can do something in between, and it's a text interface to TheoremDB. So I mean, ideally, like I'd like the TheoremDB interface to be also written in my language, but it's pretty simple to write just a SQL wrapper. I think you could write that in whatever language and not be too locked into that choice. You can always rewrite it pretty easily. And basically what I want to do is have a textual representation of the theorem that's just easy to like write about when you're working. So like step 1, step 2, and then like, I don't know, you have like step, sub-step, blah, blah, blah. And you should be able to parse this into TheoremDB. You should be able to, basically from a CLI, and you should be able to sort of look into TheoremDB, get various definitions, theorems, information like that from the TheoremDB CLI itself. And so the proof visualizer would be driven by TheoremDB, would just display what TheoremDB is showing it. But obviously it would be nice just to also have like a basic CLI interface, whether or not that's actually what the proof visualizer will use. So I was thinking we can just do that. That's also another sort of parsing thing. It's kind of like parsing Markdown or something and storing it in the database. And at the very least, maybe that can help us start making these videos, because the proof visualizer, I have some pretty like kind of out there ideas on visualizing, and a lot of it will be aesthetics. It's not even that it would make it better to teach necessarily, like a lot, but I just think it would be really cool. I think a textual representation with the sort of interconnected semantics of TheoremDB would be great. So yeah, I'm thinking we can do that, get 80% of the way there without the proof visualizer, start making math videos, and work on the proof visualizer via the language mail in parallel. So yeah, I'm still debating which of these two we'll do, but we'll probably do one of those. I'm honestly probably leaning towards the text parsing, which I guess would also use perhaps the Unicode library. So yeah, until next time.